Okay, so we're gonna show the mechanism for a bimolecular nucleophilic substitution reaction. Um, so right here we have our, first we have to identify what our nucleophile is and what our electrophile is. Nucleophile usually has a negative charge, so if we add the formal charges here to the sodium hydroxide, we can see that sodium has a positive charge, hydroxide has a negative charge, and hydroxide has at least one lone pair of electrons. In this mechanism, we're just going to use one, so I'm just going to add a lone pair. But we also have another two sets of lone pairs, or a set of lone pairs. Okay, so what we have to show is we have our little plan here is we have to show how the electrons flow from the negative charge towards the positive charge or partial positive charge. And sometimes these carbon halogen bonds, they're partial positive and partial negative. Although iodine is not super electronegative, it's not very electronegative, it still polarizes this bond right here. It's not a very strong bond either. And what we're going to show here is the flow of electrons in order for us to form this bond right here between the oxygen and the carbon. So what we're going to show is this pair of electrons are going to attack the carbon atom, so that's a nucleophilic attack. And as you're forming that bond, the carbon iodine bond is going to cleave or break, and we're going to end up with an iodide in the product side. So those two electrons are going to end up with the iodide. I'm going to put them at the top here, and as that happens, iodine still has like its own lone pairs of electrons here. I'm just not showing them. But overall, it's going to end up with a -1 charge on the product side. So the sodium cation is still present there. So it'll just be there. It's a spectator ion. So the iodine ends up on the product side as an iodide, sodium iodide, and we end up with making an alcohol here because we made a oxygen carbon bond. So we made an oxygen carbon bond, and that's what the arrow here is showing. It's showing that we're forming an oxygen carbon bond. So if we wanted to like look at it in like a little bit more detail, then let's see what's happening here. I'm gonna copy this, duplicate, and I'm gonna copy this one, duplicate here. Like, how did we end up with this? What's happening? So I'm gonna put two electrons here. So what's going on? This oxygen is approaching here, right? And as it approaches, it's like, okay, I'm gonna make a bond here. So as it tries to make a bond there, well, something's gotta go. So it makes a bond, this breaks a bond, so this iodide ends up over here on the right side with two. It doesn't have a bond anymore, it just has a pair of electrons. And as this oxygen over here approaches, now it's going to form a bond. So these two electrons are going to form a bond. So that's how you end up with your alcohol on the product side over here. So you broke a bond between the iodine and this carbon over here, and you made a bond between the oxygen and the carbon. That's how you ended up with your product. Okay, so that's an Sn2 mechanism. That is